All right, in this video, we are going to take the limit, right, of this algebraic function. It involves the square root right here. All right, it's the limit as x goes to 7 of that. So what we're going to do is just plug in the 7, right, and see what happens when we do that. All right, so if I plug the 7 in, I get 7 minus square root 7 over 7 minus 7. Okay. All right, and on the top, I have the square root of 7 minus the square root of 7. That's just going to be 0, right, because they're the same number. And on the bottom, I get 7 minus 7. That is also 0. All right, so we wind up with 0 over 0, which, remember, in a limit problem is an indeterminate form. It means nothing, right? We really know nothing about what the answer is based on that. All right, we have to keep working the limit problem until we figure out how to get something else as the answer. So in this type of algebraic problem, what we're going to do is to do what's called rationalizing. So here the square roots are on the top of the function. So what we are going to do is we are going to multiply the top and bottom, right, of this expression by the same parts over here, square root x and the square root 7, right? But instead of being joined by subtraction, right, they are going to be added together. All right, and so what is going to happen here, right, when we do that is when we multiply this expression out, we're going to see that the result of this is going to clear out those square roots from the numerator of this function. Okay, so that's the process of rationalization. Okay, so that's what that's called. All right, and so the thing is we can't just go ahead and multiply by whatever we feel like it without any consequences, right? Math would be a lot easier if we did that. To keep everything balanced out, right, what we are going to have to do is to multiply the bottom part by that same expression to keep everything balanced out, right? So in effect, right, this expression over here is equal to 1, okay? And so that means that we're not changing the value. We're really just changing the form of this function here, okay? All right, so next up is we are going to carry out some of the multiplications here, and the key is, right, do not multiply everything out. Up here where these square roots were originally, right, on the top, we are going to carry out these multiplications here, okay? So these expressions have to be FOILed out, so it's going to be the first times first, so square root x times square root x. That's going to come out to be just x when you do that, all right, because it's the same square root expression. All right, then we're going to do outer times outer, right? So that is going to be square root x times square root 7. Next, we're going to do inner, square root 7 minus square root 7 times square root x. And then do last times last, so minus square root 7 times positive 1 square root 7, right, is going to be minus 7. Again, square root 7 times square root 7 is just going to be 7. 1 was positive, 1 was negative. So therefore, it will be minus 7 on top. Okay. Now, one of the other keys to this problem, right, is do not multiply out the bottom part on the other part where the square roots weren't in the original problem. Okay. There's nothing mathematically wrong with that, but it's just going to be counterproductive in this problem, because what's got to happen in this problem is that something is going to have to cancel out. And, what's going to cancel out is this x minus 7 over here. So if you go ahead and FOIL that out like you did on the top, that's really going to obscure that. And most of the time people miss the fact that something cancels out there. So here I'm just going to keep these two factors next to each other. I'm not going to actually carry out the multiplication. Okay. All right, now it's time for some simplifying, right? So on the top, I have this x. All right, and if you notice here, I have square root x times square root 7. Here I have minus square root 7 times square root x. These two terms cancel each other out, okay? You might say, hey, well, wait a second. These are kind of backwards of each other, but remember, I can just rewrite this as square root 7 times x if I felt like it. So I have one of these, and I take away one, so I'm going to have 0 of those, right, which is just 0. Okay, and then I have this minus 7. So these things cancel each other out. All right, and it's no coincidence that happened, right? I told you at the beginning, if I multiply by the same parts, square root x and square root 7, but joined by the opposite operation instead of subtraction, change it to addition, that it's going to wipe out all of the roots on the top in this particular problem, okay? So we wind up with just x minus 7 on top, and that's important, right? Because like I told you, what has to happen in this problem is that x minus 7 on the bottom is going to have to cancel out, okay? And so now you can see the bottom is completely factored, the top of this is completely factored, and there is a common factor of x minus 7, so the x minus 7 can be canceled out. And so I wind up with the limit as x goes to 7 of 1 over the square root of x plus the square root of 7. Okay. Now that something's canceled out, I can try this limit again. In other words, try to plug in the 7 and see what I get. When I do that, I get 1 over square root of 7 plus square root of 7. That comes out to be 1 over 2 square root 7s, right? I have 1 square root 7 here, and I'm adding another one. That's going to come out to be 2 square roots of 7 there. So you have 1 over 2 square roots of 7. You will need to rationalize this expression. So to rationalize this expression, what you would do is multiply top and bottom by square root 7 in this particular case, right? Because then what will happen is you'll get on top square root 7 times 1, which is square root 7. On the bottom, right, you'll have 2. And then square root 7 times square root 7 is just 7. All right. And so final answer, right, on this problem is square root 7 over 14.